good afternoon. I know it's been a long day and you're probably really tired, but hold in there. It's going to be a great presentation. So if you need a drink, there's ladies coming around. Please get yourself a coffee, stretch your legs, because we're about to talk to Hydrogenics about their update in their product development, and it's pretty cool. And to talk to us today, it's going to be the Business Development Manager of Hydrogenics, Mr. Mark Kammerer. So could you please welcome him on stage? Welcome, and thank you for taking the time to speak with us.
Oh, thank you, and thanks everyone for joining us.
Before we start, I'd like to point out that this is a public forum, so if you ever have a question, just put your hand up and I'll bring the mic down to you. So let's start off with the latest news from Hydrogenics.
Oh, okay, yeah. We have news in different product groups that we're involved with, or businesses, fuel cells, stationary and mobility, and electrolyzers, both alkaline and polymer electrolyte membrane technology. And the larger, more exciting, or most exciting latest developments on the fuel cell side are heavy-duty fuel cell bus mobility, a fuel cell called the Solarity product that we co-developed with Siemens for Siemens drives. And the other is large-scale PEM electrolyzer, 1.5 megawatt that we're delivering in a second project with E.ON in Hansa. Although I won't focus on that too much, or we're not going to in this session, because my colleague spoke on it earlier this afternoon. So we'll like to speak more about the mobility fuel cells.
Fuel cells are going to be the star of this conversation.
Yeah.
So we discussed a bit earlier about the multiple applications. Could you just outline some of the applications that are possible with this new fuel cell?
Yeah, okay. Yeah, the main ones that we're proactively focusing on is buses, trucks, heavy mobility. So they must be interested in electrolyzers, but
Probably.
And backup power, yeah, for telecom and data center. And then the other trend going on is for larger scale power generation from byproduct hydrogen, or off-grid, where the hydrogen is made from excess electricity stored in hydrogen by electrolyzers.
Okay, so focusing on fuel cell, and you mentioned Solarity. Could you tell us a bit more about it and just how it works, and then we'll go into the next one?
Yeah, sure, yeah. Solarity is a product that we announced in November of last year. This is the launch here in Europe, where we're publicly showing the product. It's over at our exhibit stand, which is directly behind the control desk there. And it's basically a module designed for fuel cell buses that eliminates the need for a power electronics boost voltage. So that is really the key major innovative step, is to design a fuel cell which runs overlapping the voltage range of the most common electric drives. So in the case of Siemens, they've delivered the majority of the fuel cell bus drive systems, and with our product together with theirs, they're already pre-validated, compatible software interfaces, all's done. The OEM has no development. The system goes in, they get a complete powertrain. And that's a drastic improvement from the past, where the initial ones, the OEM was getting almost a bare stack or a part of a system, and they'd have to develop the rest of it, which is very time-consuming, painful, and with the additional components like DC-DC is also prone to failures.
And you're going to tell me that Solarity Plus does something better than that?
Well, the difference between the Solarity and the Solarity Plus is the Solarity is the fuel cell itself. It's a system package with all the controls already included. What the Solarity Plus brings is it's bundled together with the Siemens drive. So Plus just means you get a bundle either from Hydrogenics or from Siemens from one hand, from one supplier, finished. All you need then to add for the integrator is the hydrogen storage and connect it to a cooling radiator, and that's it. That can also be done by Hydrogenics. It's one of the businesses we do as well.
And the ease of use and implementation, is it really complex to deploy, or is it one of the simplest to do?
No, well, like I said, it's a complete drivetrain, and compared to up till now, before Solarity, this is the case with all suppliers. You need to first, before you could use a fuel cell with an electric drive and a hybrid with a battery system, you need a boost converter, because the voltage coming out of the fuel cell is normally something in a couple hundred volts, but the DC bus needs something like 500 to sometimes 700 volts. So that needs to be boosted, and you have to do it some way. And the DC-DC converter is usually a very expensive piece of equipment to develop. And usually in the initial developments of those, there's actually fairly high failure rate. And when you look at failures of fuel cell buses, a lot of it's coming from the DC-DC. And in the low volume, the DC-DC sometimes costs us almost as much as the fuel cell, up to say 50% of the fuel cell, even after the development cost is paid. So it's a really nice piece of kit to be able to avoid and get rid of and not have to worry about.
So you essentially, Solarity and Hydrogenics is building on the trend of just keeping up with innovation and technology and taking it one step forward.
Yeah, absolutely. In fact, the idea of the Solarity for us is not new. It is just continuing with development we've had in our HD series of packages, which include not just the fuel cell stack, which is useless. It's not useful to anybody. It's like an engine block without pistons, without fuel injectors, and so on. What we've delivered is an engine where you have to find and develop a new, say, turbo compressor. That's all included. We've added even more to the system, like reverse current protection, pre-charge, and basically everything that the system needs, it's included.
Okay, and so people are going to ask, there's other companies here who are selling systems for buses or for larger vehicles. Why Hydrogenics, and what is your unique value proposition?
One of our strengths is we're very experienced in the complete integration, even as the registered vehicle manufacturer, which we've been doing since 2005. We integrated from ground zero to a complete certified, registered as the vehicle manufacturer fuel cell buses. Actually, we could say it's Europe's second largest fleet. There are 11 buses in Spain, Germany, and Italy. And that's the best way to be able to help customers and to integrate a complete system or do a turnkey package. So we have done several turnkey packages for bus OEMs. That's one thing that our competitors really haven't been doing and don't have the facilities to do in Europe. And the other is that we customize. We're adjusting, like with Solarity, is basically adjusting the cell count, the form, the shape to fit the customer's requirements. So that's one thing. If you're dealing with other fuel cell suppliers, you get it, here's the box, that's it, take it or leave it, we can't change it. We've recognized that at the end, every integrator or vehicle manufacturer is going to want something specific, shape, performance, voltage to their specific requirements.
So if I had a bus and I wanted to put the Solarity Plus in, how much how many kWs would I need to run a 12-meter bus?
Okay, yeah. It's an interesting question. Some of the first buses around 2000 came out as 200 kilowatts. But that's because they don't have a hybrid, and normally with a diesel you might need, those are usually 200, 300 kilowatts as well. But with a hybrid system combined with a battery and the electric torque you have from the electric drive, in most of Northern Europe, where you have flat topography, 60 kilowatts of fuel cell power is absolutely enough, in fact, comfortably, to operate the bus. So it's a smaller engine than lower cost. And for acceleration, the battery provides the acceleration power, and the fuel cell then recharges and takes the base load. So if you're in Southern Europe, or in a more, let's say, warmer country, then in the summer you have a need for air conditioning. So that's when you need 90 kilowatts, 120 kilowatts, 150 kilowatts. Northern Europe usually don't need the air conditioning, and for the heating, actually the heat can come from the fuel cell. So the colder winter is not an issue in terms of energy requirement.
So right now, Toyota's car takes 100 kilowatts. You're saying your bus is going to overtake that car on a motorway?
Absolutely not, and it's not designed for that. So the bus is designed for stop and go. It's usually an inner city urban transit bus, so there's stoplights, there's bus stops. So the bus is designed there for 50 kilometer to 70 kilometer hour zones. The Toyota car is designed to be able to go 150 kilometers per hour, and that's where you need the power. So if you're running the bus on an Autobahn, then definitely you would need more than even 100 kilowatts for the bus itself. So the combination of how much battery power, how much fuel cell power, that is determined by the drive cycle of the bus. If I mentioned flat areas, Northern Europe, 60 kilowatts enough. You might have in coastal areas of Italy, Naples, a lot of hills. Then you need a higher power. So it's just a matter of additional fuel cell modules and fewer battery modules. So the combination is really, it's limitless. It can be a battery dominant, it can be fuel cell dominant, all depending on what the drive cycle requirements of the bus is.
Let's talk a little bit about the fuel, since you've mentioned it. For Solarity and for your solutions, where does the fuel come from? And then leading on from that, I'd like to know how many kgs of requirement.
Okay, yeah, all right. Maybe I'll start off with that. The typical fuel cell bus is using 20 kilograms on average for a standard 12-meter bus. So that's 20 kilograms per day. Just to put it in perspective, where the fuel will come from, most of it's coming from natural gas today, but we see the future is coming from renewable energy. And with taking renewable energy and putting that through a water electrolyzer, then you have absolutely green, renewable, sustainable energy and fuel that you can use in fleets of vehicles. And if you look at the bus programs that we have in Europe, there's the CUTE project, CHIC project, High Velocity. In the CUTE, there were 6 electrolyzer fueling stations. We delivered 4 of them. In the CHIC, we delivered the majority, well, all of them, and also High Velocity. So it's cities like Aberdeen, Bolzano, Sanremo, Brugg in Switzerland, Oslo in Norway, Hamburg, Stuttgart, and so on. So, but what's really exciting, we think that for a lot of the topics here is large-scale electrolysis. 20 kilograms a day is one bus, but that doesn't make a fleet. And with 100 buses, so that's 2,000 kilograms per day. That's only 5 megawatts from an electrolyzer. Most of the larger cities, they have in the range of 1,000 buses in the fleet. So that's 50 megawatts. Now we're getting into a range where the electric utilities start to get really interested to use the electrolyzers for energy storage, grid balancing, and demand response ancillary services. So we see, and 50 megawatts is really within reach. It's absolutely no problem with the electrolyzer technology that you see being displayed here. And so once that's validated, really what we see should be more encouraged is with the cars. It's very difficult to have fueling stations everywhere. So Toyota is very, very brave and ambitious to introduce the cars first. But if they introduce the buses first, they could fill their buses with only one fueling station per depot. Whereas with the cars, you need fueling stations everywhere, and you don't know what the demand is from day to day. It's at random. With the buses. You have a constant every day the same demand. Kilograms. So that's a very interesting customer of the gas for an owner of a fueling station.
And it provides for really good economics for the solution as well.
Yeah, that's absolutely the perfect point, that the smaller fueling stations for vehicles, for personal cars, are much more expensive per their capacity than large scale. So the bigger the systems, the lower the cost per kilogram to produce. And the excess capacity of the larger plants then can deliver fuel to the personal cars as well, and then expand the car network from that.
I could keep asking Mark questions and questions, but if anyone else has, please raise your hand and I'll bring the mic out to you. So we have one question.
Hi, Mark.
Hi, Brian.
So one question, if I understood you correctly, you were talking about the implementation of this. Everyone knows the hybrid design of a battery and a fuel cell is already proven. They have the range, they're great buses. But I understood that you're talking about installing these systems into existing bus designs, largely. Has anyone specifically designed the whole bus from top to bottom for a hydrogen fuel cell? The reason I ask this question is because stop-and-go traffic always raises the issue of, are we recovering energy while braking, for example? You know, we're all worried about efficiency, and it makes sense to actually rethink the design with this new technology. Is anyone doing that?
Yeah. They are, and we're working with one company, which it's not public information, but it's a major European bus manufacturer. But they're actually taking it a step further to what you're saying. They're making a standard chassis which works with all of the different combinations of the energy. So it's an electric battery-based at the standard version, and to make it a long-range battery bus, there's a pack which clicks on the back, which is makes it into a long-range battery, a battery pack. If they want to make it a diesel bus, they would put a diesel generator on the back. If it's a compressed natural gas, another either click on, or it could be an articulated section that adds onto the bus. So that is interesting to the bus fleet owners, because then they don't have so many different versions of buses. They have one chassis, and they can convert them back and forth. They can convert a battery bus to get the pack for the hydrogen fuel cell. That would click on the back. So depending on their mix of fuel and the economics of the fuel as well, they can combine, and they have a lot more flexible fleet, but with a common chassis platform.
Are there any other questions?
Hi, my name is Eyal. Okay. Sorry. The question is, how do you carry the hydrogen within the bus, and what problems do you have to overcome through regulation, etc., in order to have those buses
Yeah.
working in the streets?
Yeah, good question. So the majority, I would say all of the fuel cell buses are using carbon fiber tank technology. A lot in the cars, it's using 700 bar, but that's not necessary for buses because you have a lot of space on the roof for the carbon fiber tanks. And so that's 350 bar. Sometimes it can be 200 bar if depending on the number of tanks they're using. And the lower the pressure you have, then the more efficient your system is overall, because you don't have to compress it as much. But in terms of the regulations, at the beginning, year 2000, 2001, really in Europe, I mentioned the CUTE project, that's the Clean Urban Transport for Europe. That pushed the envelope and got through with TÜV Rheinland in Germany, the first certifications. And after that, the pathway was clear for the others. So that was led by Daimler. I have to hand it to Daimler, together with TÜV Rheinland as well. And then after that was it's very easy. I mean, you have to know what you're doing and know the regulations, but the certification's not an issue.
So we're running a little over time, and I'd point other questions to booth C59, which is right there. But just before we leave, I know that Mark was really excited about one particular breakthrough, which is in the multi-megawatt solutions. And I was wondering if you could quickly touch on that before we say goodbye today.
Yeah, okay. Yeah, this is another quite a step up in power for our stationary. So I covered a lot on the mobility, but on the stationary fuel cell side, we're known for a data center backup rack, which is based on 10 kilowatt modules, up to 3 in a 19-inch rack. So maximum 30 kilowatts per rack. But our newest fuel cells, the 30 kilowatt module, is the same size as the 10. And with adding in and making some changes, we can put 4 30 kilowatt modules in a single rack. So that's 120 kilowatts in a single 19-inch rack. 10 of those racks is 1.2 megawatts. And so that's what we've been starting to deliver. We haven't made any product launches and no big splashes or promotions or anything. It's just a natural, organic product introduction that we've made, but it's something that I really think is very significant for the industry, and I see it going that way for other suppliers, most likely in the future.
Well, Mr. Kammerer, thank you so much. We're out of time, but thank you so much for talking with us and sharing all this news. And again, I encourage you, their stand is right there. Go ask questions, get more information. Thank you very much. Thanks. And thank you all for your patience and for being in the audience today. You've been fantastic. And hope you have a great evening, and we'll see you tomorrow.